Okay, so this is chapter 5, plotting, that we'll be doing starting on page, whatever page this is, 146. So plotting in MATLAB is a little bit different than you might have done with a computer or a calculator. And the main thing that makes it different is that in most computers, when you plot something, or calculators, it kind of assumes what your x-axis is going to be from the situation that you're in. For example, if you plot something in Excel, you only need one column or one row of data, and then it will just take the numbers from the columns or the rows as your x component, and the stuff that's in the different cells in Excel will be your y component, and then you just x versus y. On the calculator, it's very much the same way. Usually your function is a function of a variable, x for example, and you have the function equals x squared, and it just assumes that x goes 1, 2, 3, 4, 5, 6, 7, and so on. In MATLAB, you have to tell MATLAB what x is going to be. You have to define a matrix or a vector that is x, and then you have to define a vector that is y. And then you have to tell it which one is going to be on the x-axis, which one is going to be on the y-axis, and then it will know what to do. Also, those things have to match each other in size. If they don't, MATLAB doesn't know what to do with it. So that's a little bit of a drawback just because you're not used to that. Most people aren't used to that. But it also, MATLAB has great advantages to plotting because you can do a lot more. It has a lot more power and a lot more capability when it comes to plotting. So, and it won't necessarily seem that way at first, but as we get into it more and more, you'll see what I mean. You can literally plot anything in MATLAB. And many computer programs are this way. Most computer programs that are programming programs are this way. All computer animation is done like this. It starts off with very simple plots and goes to more and more and more complex plots until you're plotting something that looks dang near realistic. And the other advantage that you have with computer plotting is that you can take an analog image and digitize it, and then you can manipulate it. Because once you've digitized it, you just turned it into coordinates. You just turned it into values in a function, and you can manipulate that function all you want. Okay. Some of the original digital animation, you could think of it as, was actually just digital manipulation. They take a real image and digitize it, make it into a digital image, and then manipulate that digital image just using simple programming techniques. So let's go ahead and get started. I'm going to clear everything out here really quick, and I'm going to define a variable x, which will be I'll go ahead and use x as my x-axis or horizontal axis. And I'm going to go ahead and create this vector that is going to go from 0 all the way up to 18 by steps of 2. Page 147. So go ahead and suppress that output. And then I'm going to make my y matrix, which will look like this. Dang it. I'm going to type out each individual one. So this first one has 19. X is it has 10 because it goes by 2s. So this is a 1 by 10, so I'm going to have 10 elements in my y as well. I'm going to start with 0, and then I'm going to go to, my next one will be 0.33. You can put 0.33 or just 0.33. I prefer to put 0.33. And then I'm going to put 4.13. And I put 6.29. And sometimes when people are programming this, they put a couple of spaces in just to make it a little bit easier to read. I'm going to go ahead and do that. MATLAB doesn't care if you do that. Put a couple of spaces in. Put 6.85 and 11.19, 13.19, 13.96, 16.33, and 18.17. I'm going to make sure that I've got 10 of these numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that's good. Dimensions agree. So we're going to use a very simple command, the plot command, plot. And I'm going to do plot x comma y. The first thing that I put in is my horizontal axis, or my independent variable. And my second one is my dependent variable, my y-axis. Plot xy, hit enter. By default, it brings up the plot in a separate window. So it comes up here on top of your normal MATLAB window. How do I move this thing? It's in my way. Go away, thing. Okay, here we go. So it brings it up in this window, this external window, and you can dock it. You can put it into your command window here if you want, or your whatever window. That's not command window, but your desktop thing or whatever. You can move it around if you want. And you can see here that the default also plots in a blue line where the points are just turning points on this blue line, essentially. And it also, by default, gives me a little bit of extra graph at the end of each of these things. So this thing goes up to 18.17 on the y-axis and up to 18 on the x-axis, but it takes it all the way to 20, and that's fine. Also notice that it's just called figure 1, right? So it doesn't have a name, there's no title, there's nothing on here really except the very basic stuff. It doesn't give you a lot of stuff if you just use the default. Let's see here. Yeah. So let's do another kind of a plot. Do the area plot. Area x comma y. There are many different kinds of plots in MATLAB. So what this one does is it does the same plot, except it shades in under the curve. Between the curve and the x-axis gets shaded in. That's an area plot. These can be used for different things. There's all kinds of applications for these. We can also add things to the plot like a title. If I just put title after I've plotted something, right after that last plot, if I put in the title, but whenever you're putting in something that is intended to be words into MATLAB, you have to put it in single quotes. So we'll call it lab experiment or something like that, and then you close it with a quote. They put it as lab experiment 1, that's fine too. Lab experiment 1, you have to open it with quotes and you have to close it with a single quote. And then if you hit enter, then it puts lab experiment at the top of the chart there. Right? You can also label the axes. I can do an X label, and I can label that with, what is that, time. So I'm going to put a single quote again, time, and that'll be in seconds. And then I'll close it. So the first quote mark tells me that I'm starting a word, or what they in computer programming speak they call this string. So if it's intended to be like words instead of numbers, then then we call it a string, and the string differentiator is the single quotes. So you put it at the beginning, put it at the end, and I can do a Y label as well. I can put a semicolon here and do a Y label. Right after that, I don't even have to put enter. I can do them on the same line, I think. So Y label will be, what are they labeling as? Distance. In furlongs. Or whatever. Right? Go ahead and press enter. And it puts on those labels on the side and the bottom there. You can add a grid. You can put a grid on your graph, grid on, just tell it grid and put on afterwards, and it puts a grid for every divider on the graph. You can even tell it where to put the grid, how much grid, if you want to put more grid lines in. There are ways to do that. Of course, if you want to know more about the plot command, put help plot. And it'll tell you all kinds of things that you can do. There's different kinds of plots they're showing you here. There's different things that you can add to it. You can change the color, you can change the size, you can change how points are marked, you can change the line, you can change all kinds of things. And if you click on the reference page in the help browser, you get even more information. There's so much you can do by doing in this functionality. Now, this plot will stay open until you close it. You can close it a couple of different ways. You can go ahead and just press close right here, or you can close it from the command window using the close command. When you hit close in the command window, it closes all the plot windows that you've created so far. And those plots are lost to MATLAB at this point, lost to your computer. Can't recall them. You have to remake them. You can save plots as well. So if we go back here and we create this plot again, right? You can save this plot by going up here and hitting save right on the plot. And then that plot can be saved wherever you want. It'll be written up to your hard drive, permanent memory. It's no longer just sitting around in your RAM memory. So make sure that if you have a plot that you want to save and you don't want to recreate it every time, that you actually do save it. Otherwise, you can close out of the window and it'll go away, or you can hit close here. And if you have several plots open, which can happen, you can have several plots open at once. Let's do a plot XY, and then let's do an area XY. One right after the other. So now I've got these, I can go look at all the windows I've got here. If I go to my figure here, oh, actually it didn't do it. So if you plot one and then plot another right away, you have to put something in between them, which I think they'll teach us here in a second. I can't remember what it is. But if you do two in a row without, I think you have to use a hold command or something, without holding a plot, without doing something, then it just overwrites the plot. So this plot is the only one that's open right now. And if I made another plot, it would erase this one and put another one in its place. But if you do, I believe it's hold. So let's try hold. And then I do another one of these plots. And let's see if it keeps it. Apparently it doesn't. Well, I can't remember exactly how it's done, but we'll learn that in just a second. We'll remember it here shortly. You can see how much I have an opportunity to program in MATLAB during the year. I'll have a lot more this year, though, hopefully, because I forget little things like that all the time. Let's see, titles, grids, we did that. Okay, creating multiple plots. Ah, yes. Okay, that's how you do it. You do a figure command. So if we go up here and we plot XY, and then we use the figure command, figure, and we do a 2, that opens up a second figure window. So now we have 2 plots open. Figure 1 is the one that I already plotted. Figure 2 is an empty figure window. And then I can plot my other area, my area plot, and it'll put that one in the second one, I believe. Let's see, yeah, so now I have 2 open. I have figure 1 and I have figure 2. Right? So then if I go to my command window down here and I go to close, let's see what happens. It only closed the first one that I opened. It'll close the windows one at a time from the first one to the last one. But if I want, let's go ahead and open figure 3 window, and then let's go ahead and plot again the first plot. So now I have two figures, and I can go ahead and dock both of these. I could dock this one, and then I could dock this one, and what it's going to do is it'll put them in the same spot with tabs so that I can go back and forth. But if I want to close them both at the same time, I just go close all, and it will close both of them at the same time. Sometimes when you're doing a lot of programming, you end up having a lot of figure windows open. And it's a good idea to know how to close them all and just get rid of them all so you can start with a clean slate. Not have to figure out which window you're looking for. Okay. The use of the pause command, which I've already taught you, is very useful when you're doing plots, because when you're creating a program that is plotting things, if it's plotting multiple plots, it will overwrite the plots unless you tell it to write it in a new figure. But if you want the user to be able to stop the program and take a look at each plot as it's plotted, then it's a good idea to use a pause after you've plotted something. It can be really, really helpful. Okay, I have an emergency with one of my students really quick. I just got an email. I have to answer this really quick, so hold on just a moment. I have students taking a test at the moment. So I'm going to take a short break.
It was a great name. I think I loved it.
Okay. Let's see here. MATLAB. Okay. So, plotting functions, more plotting functions. Labels, pause, figures, hold. Okay. Oh yeah, okay, so let's do something else. Let's do, this is starting on page 150. We're going to overlay a whole bunch of different plots on top of each other. This is kind of fun. So I have, let's go ahead and clear some things here. Let's let x equal, we'll go from 0 in steps of pi over 100. And we'll go to 2 pi. So that's our first array, 201 elements in it. And then y1 will equal cosine of x times 4. So just a couple of functions of x. y2, so we'll go ahead and plot that. Let's plot x and y1. See what we get. Go ahead and dock this. So just your standard cosine curve. It's got a nice little shape to it. I want to show you what happens if we change this a little bit. Instead of x going from 0 to pi, 0 to 2 pi in steps of pi over 100, let's do pi over 10. And then let's plot x, y, 1 again. Problem. We have to redefine y. Now we can plot x and y 1 again. So why do they look so different? In the first one I had x going from 0 to 2 pi in steps of pi over 100. In the next one, I had x going from 0 to pi in steps of pi over 10. What's the difference? Which one looks nicer? Any opinions? Is anyone still there?
Yeah. We're typing.
I mean, which one looks like a cosine curve? Does this look like a cosine curve? Absolutely not, right? But why is it so choppy?
Because it's only 10 increments.
It's only 10 steps. We're only plotting 10 points between 0 and 2pi. So you can actually count them. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. I mean, there's not, not 10 steps. It's more like 16, whatever. It's 21 steps. But it's very few steps, right? These points are separated by so big of steps that you're not getting any of the detail. The precision is not there. So it's important in MATLAB when you're plotting something to give yourself the right amount of precision for what you're doing in your plots. Now, if your data is spread out over a certain number of, over certain distances, you don't really have any choice. If you only have one data point for every 10 seconds, then your x-axis, if it's time, has to be every 10 seconds. But if you're trying to plot a cosine curve, and you can choose how far apart to put your points, you might as well choose more points than fewer points. It doesn't make much difference to MATLAB. MATLAB can do it just fine with 1,000,000 points. A million points, 10 points doesn't make much difference to MATLAB. But you might as well choose a larger number to give yourself a better chance of actually having a nice plot. So we choose x from 0 to 2pi with separations between our points of pi divided by 100. And we go ahead and use that for our x, and we calculate our y using that x, and then we plot x, y, 1, and we get a nice smooth curve where there are 201 points that are being plotted here, so many that you don't even want to count them, but it looks very nice and smooth. Now, let's do a different curve now. The next curve is going to be y2 equals sine of x. Good night. I can't seem to type. It never was a great typist. You want to make sure that you suppress these things. If you don't, you get a mess like that, right? Make sure you suppress these calculations that use all these 200 points. But in the end, you can still do it. It's just messy. Then we're going to plot the second graph, which looks like that. But what if we want to plot both of them? We can, but we have to do it right. If the first one is going to be your horizontal axis, the second will be vertical axis. The third number will be horizontal axis again. So x. Let's see. Yeah. And then your fourth axis will be another axis again. I'm pretty sure that this will allow me to do it this way. And then we go ahead and press there. So you have to have x-axis, y-axis, x-axis, y-axis, x. And you can do this ad nauseum as many times as you want. So it'll just plot them one on top of the other. And you can see that it automatically plots them in different colors, which is nice. And we're good to go. If you really want to impress your friends when you're doing, if you're working on your programming and somebody that you want to impress comes in, you just type in this right here. Type in peaks. Sorry, peaks. And pick a number between, like 0 and a gazillion. Do 100 if you want. And then do a plot of that. Makes it look like you're doing something really, really cool. Like you're an amazing programmer. Right? So you get this really cool figure out on your screen. And let's undock it and make it big so that everybody can see this cool thing that we're working on. And of course we're working on something cool. Aren't you working on something cool? And then you can even rotate it around and take a look at it from different angles. Then it just makes it look like you're super smart or something. Anyway. The reason that they have that built into there is because that is the function that is the logo of MATLAB. So that kind of peak thing that you see when you open up MATLAB, that is the function that it comes from. So that's why they put that there. Anyway, let's see. Complex arrays. Okay, the next section, the next part of this is the plots of complex arrays. We're going to skip over that because we're not going to mess with complex numbers because there is no math prerequisite in this class. We don't want people to be confused by complex numbers. I think most of you understand them, but I skip it anyway because it's what we're supposed to do. Then we're going to move on to page 154, 5.1.2, line color and mark style. And this is where you get to mess around with the different styles of plotting things. So it's not really technically challenging, it's just how do you do it. And that will take us all the way through. We'll also do subplots. That'll take us all the way through to 5.3, where I'll probably save 5.3 until next week. Probably come back and finish chapter 5 next week. Because once we start getting into the more difficult plotting techniques, if we go too far into them, we'll have to keep going or not go into them at all. You don't want to start them and come back to them. It just gets too confusing. So, page 154. Again, if you go to help plot, you find all kinds of information, of course. And one of the things that they tell you is what you can do to change the points and the lines and styles and colors and everything else. And there are 5 basic line types in MATLAB. They list them in the table 5.2 at the bottom of page 154. Solid line, dotted line, dash, dot line, a dashed line, and then no line, which is self-explanatory. And they kind of show you, they show you in the second column there what the indicator is. That means that's the thing that you type in to MATLAB to tell it which one of those to use. And then they have the point type. They have many different point types: hexagram, pentagram, triangle, right, all these different things. And so if you want any of those, you use these indicators. You use a dot or an O or an X or a plus or a sign, a star, asterisk thing, so on and so forth. And then they have 1, 2, 3, 4, 5, 7, 8 colors that you can use, and you indicate which one you want to use those with a letter. Where do you indicate it? Well, you indicate it in the plot command. So, well, for example, we could use plot peaks if we wanted to. If you do plot peaks, and then after you're telling it to plot the peaks thing, you tell it to plot instead of instead of a solid line, we want it to do a dotted line. Then we go ahead and we do we do the open quote, because this is going to be a string command, and we do this semicolon or the colon for the dotted line right there. And then we go ahead and let's see. That's oh, they're doing a point type as well. Okay. So the first thing that you would do is the line type, and then the second thing is the point type. So each of the points can be given a shape. They use the O, which means that it's an open circle for the points, and then they want those to be black, so they use a K, and then they close this up. So this is dotted line with points indicated with the open circle and everything in black, and let's see what it does for us. So you can see that it changes the graph dramatically. Each of the points now, instead of having no indicator, because before it was just lines, now has an open dot, and you can see there's a lot of open dots there. They overlap a lot. And then each of the, and if we zoom in, we can actually see them better. Should be able to see them better, yeah. So there's each one of those open points. So each one of those open dots there is one of the data points that is on this graph. And then the lines connecting them are dotted lines, right? And then everything, of course, is black. And you can change that, I mean, to anything you want. You could change it to, what are the dot dash line. So we do the dash dot line. You do a dash and then a period. And then we could change it to magenta. And then, or it's not magenta, change it to triangles. And then change it to magenta. Like this. And hit that. And it gives you this. And if we zoom in, we can see what it's done. So we've got triangles pointing to the right, and we've got the dotted dashed line, and in magenta. So you can pick and choose anything you want, right? You got lots of different things you can choose. And that's for differentiating between different sets of data or different whatever. Very useful when you're making graphs for scientific papers or whatever else. Hold on just one second. I'm going to take another quick break. I'll be back in just a few minutes.
What are you talking about? I caught my neck and it was loud. Tell me when you want to I just want to know. No, because earlier I remember he was like, wait, is everybody still there? And we were like, oh, yeah, we're still here. So that's when you leave one. We just gotta leave one person behind. Who volunteers this week? 6 minutes. I'm pulling seniority on purpose. Nice.
Even if it wasn't down to that, it would still win my opinion.
You're right, honestly. Well, he knows his role, that's good.
Yeah, it's been my role
We'll
since
start
third
talking
grade.
rockets and we'll be good.
That's true. I didn't know rocket got launched. I watched too many.
Me neither. I would love to drive that car, honestly.
And I just keep thinking Armageddon. Pretty soon, like in 5 years, that some bitch gonna come crashing to Earth. Boom. Seriously, they could have put a pin on him or something. Elon didn't own the company that made it.
Oh my god, I bet you got enough money to buy one.
Yeah, no kidding. They're like probably like $3,000.
Most people have enough money to buy it.
I think gift them. Yeah, okay. They just want to get rid of it.
Got $5 in Wendy's, I'm pretty good.
$5. Maybe. Ah. Check. That's what I do, bro. It's not hard, it's very tiny.
That's why I'm avoiding it. No,
I just keep clicking on this task.
Actually, last two problems.
You just gotta go. It changes the celebration every time. I mean, of the like sex that it has. Grand Master. Yeah, which is.
Well, that's pretty much, you shut the class and you take some pictures and homework.
Because it's Queen, you dummy. That's why I looked at you for so long.
Okay, sorry for that. Just putting out fires here. You guys ready to go again here?
Yeah.
Yeah.
Okay, so now if you want to change the line width on your plot, you can do that as well. So do that same thing. It's a string command, so you have to put it in quotes. Do line width, and that's the only thing you have to put in quotes. And then after that, you put a comma and you choose your line width, and that choice is made as a number from. It's essentially like the number that you use for like font size, and 0.5 is the default. And you can go up to, I don't know how big actually. You can go at least to, I think 5, but I think it's, I don't know exactly what it is. But you can change your line width to different sizes. Let's change it to 3, for example. You can go ahead and hit return. You can see how it gets, the lines get much thicker. You can also change your marker size. So if I go back to my plot that uses the triangles, and I can go ahead and do a comma, and I can do in quotes marker size, and you have to use the correct capitalization. So marker and size with no spacing between them. The M and the S are both capitalized, and then we go ahead and close that quote. Oops, single quote. And then put a comma, and we can change it to 3 or something like that, make a bigger marker size. And take a look at our, whoops, I forgot to, back to here. And it'll change the size of the triangles that we make in there or whatever. It actually might be the same size, it might be smaller actually. I don't know if it made them bigger or smaller, but you can change the marker size, you can change the line width. Of course, you can change the marker. You can change all kinds of things, and there's lots of different ways to manipulate your plots. Okay, so let's see here. right. Another command that, another table of commands that you can use when you're dealing with plots. On page 156, you've got the axis command. If you use it without any inputs, it freezes the axis at its present configuration and uses that same axis. So if you're plotting multiple plots and you freeze the axis, then it makes sure that each plot after that is on the same axis, so that they're on the original scale that they were to begin with. Then you can also put the axis on a set size that you want, and in that case you have to enter in some numbers for your axis, and we'll show you how to do that in just a second. You can also set axis to equal, so that the x and y axes are equal scaling. You can put on a legend. You can put text on your graph, a text box. You can also put, they have one that's called a G text, which the text box is one that is placed at a specific coordinate on the graph by the numbers that you put into the text command. But the G text is more of a graphical user interface thing where you can drag it around on the plot. So all those things are just different commands you can use, and we're going to go ahead and use a few of them here. So let's see here. Let's use the axis command. Why not? So let's do the axis command, and inside our axis command, we will use the following parameters. Put in an array of -2, (3), (0), (10). The first two numbers are the range on the domain on the x-axis. The last two numbers are the range on the y-axis, I believe. Let's try that. So that's correct. So your domain now goes from -2 to 3, and your range goes from 0 to 10. So the first two numbers are x, your second two numbers are your y. So it sets the figure to a specific parameters on the axis. Of course, if you set axis equal, then you don't have to put parentheses for this, you just write equal afterwards. Then it just sets them equal. In this case, goes from 0 to 1, 0 to 1, good to go. Also, you can clear your figures by doing a CLF. That clears all the figures. And then if you look at your figure window, there should be nothing in it. It will still be there. It doesn't close the window. It just clears the window. Let's see, what do we have here? Do we still have an X and Y? We do. Well, we have an X and a Y1. So let's go ahead and plot some things here. Well, let's not even, well, let's go ahead and do it. Okay, so we're going to plot X comma Y1, and they have a bunch, they're going to put in a bunch of colors and things. So if I want to, if I want to plot multiple things on the same plot, and I want to change the colors to my specifications, if I want them to be specific colors, then I need to indicate that in here after each plot. So X1, Y1, and then if I want to include a color and a line style and everything else, I need to put that in. So let's put that in. Put that in with our single quote. We'll do a dotted line. We'll use a circle indicator, and we'll do it in black, and that's fine. But if I don't do that, MATLAB will, by default, make everything a solid line. It'll assign different colors to different plots, and it will have no indicators. It'll have no points where your data is. So you just have to choose it if you want it. If you don't want it, it'll just separate everything by color. Now let's say we do another plot where we do X, comma, and then we'll do Y1 again, but this time we want to multiply Y1 times something. We'll multiply Y1 times 2. You can do that. You can do math within the plot function, as long as it's not too crazy. And then this one we want to show as Let's do this one as a dashed line, which is the double dash here. The dashed line, and we'll do that as X's on the points, and we'll do it in rosa. And then we'll do a third plot. We'll do a third plot, which is X, and will be comma y1 over 2. y1 divided by 2. And that one we will do with, what were we doing? We're going to do just the solid line, and we're not going to do an indicator on this one. This is just going to be a solid line, and we'll do it in blue, and we'll call it. Let's go ahead and make that plot. You can see the various things that happen to it. The one that's multiplied by 2, the one that's divided by 2, and the original plot there. All very nicely plotted. Same graph. And let's go ahead and let's put a text box on this. We'll put a text box, and we have to choose where we're going to put the text box on this somewhere. So we're going to choose somewhere on within the original plot. We'll go at 1 comma 100. So 1 on the x-axis, 100 on the y-axis. We'll put in the following text box. Put a single quote, and then we put in our label with a text box. And then we close it, single quote. If it comes up purple, you've closed your quote and you're good to go. Go ahead and hit enter, and look at your figure. Go ahead and dock the figure if you want, so it makes it easier. Where's our text box? I don't see it. Let's open that up again. Where did our text box go?
If you label plots with text, what did you type?
It doesn't matter what you put between the. It doesn't matter what you put between the parentheses, because that's just what it's putting in there. I'm just trying to figure out why it didn't put it on here, because it should be on here. It should be on here at 1. No, at 1. Oh, because it's at 1/100. Why did I want me to put it 1/100? There's no 1/100. Let's put it at 1 and 1. That should make more sense. There it is. At 1/100, that was off the graph, right? It was way up off the graph. I wanted to put it at 1/1 where it's actually on the graph. So here's my text box on there. And that's great. And you could put an X label on it and a Y label and a title. We've already done that before. And you could choose your axis to be bigger so that your text box actually shows up. But whatever, it's just kind of up to you what you're doing. If you put a text box on and don't tell the graph to widen out to wherever that point is, it won't show you the text box, because it doesn't consider the text box as part of the graph. And I just wasn't paying attention to. They're using a different set of data than I am, so their data would have shown that box. Mine doesn't. You can also use Greek letters in these things. The Greek letters, you use a \alpha, \beta, \gamma, and so on and so forth. You just spell them out. There are other things you can. There are so many things you can do. It's just kind of ridiculous. So that pretty much takes us to the end of section 5.1. They do an example here where they use a great deal of mathematics that not really all that important, but probably the example 2 is the more interesting one, where they do a ballistics example. And the ballistics example is interesting because you get to fire a cannonball and see how far it's going to go. They give you the equation for doing that. They give you the equation for the angle and the distance that it travels, and then it plots it out, which is kind of nice. But still, it's no different than we've done with examples in the past. It's just entering things in the way they tell you to enter them. But plotting the results, just remember that you have a lot of different options that you can choose from, so make sure that you use the help plot function to enter in that syntax correctly, and then try it out and see how it works. Remember that with the plot function, it erases your previous plot and puts a new plot on unless you tell it to save the plot or to create a new figure for your new plot. So that if you want to save a plot for some reason, that you save it or create a new figure or whatever else. Don't just let it overwrite. That's a common frustration from people using programs, that they forget that things are not saved automatically. You have to tell the computer to save it. Otherwise, it just overwrites. Okay, I think that takes us to the end of what we want to cover. Oh wait, no, we want to do one more section. Do we want to do one more? Yeah, let's do one more. Let's do one more section. It's just a really short section. This is what we call the subplot. So the subplot feature in MATLAB, which allows us to put multiple windows or multiple figures in a single window, but not overlaying each other. So if we go to page 164 rather, and we start, let's go ahead and clear some things here. We start off with our x equaling 0 pi over 20, 0 pi over 20, and pi or 2 pi, 2 times pi. So we create our x array, and then we're going to now use the subplot function to tell MATLAB that we want to create multiple windows within one single plot window, or multiple figures within a single plot window. And we tell it how many rows of plots we want first, so it's rows and columns again, just like with matrices, and how many columns of plots. So if I do a 2, 1, that means I want 2 rows, but just 1 column. So it'll give me 1 plot on top of another plot. If I did 2, 2, it would give me 2 rows and 2 columns. So it would be 4 plots arranged in a 2 by 2 matrix. And then the last number that we plug in tells MATLAB where we want the first plot to be, where we want to put the first plot, which is in the first element. So we tell it to put it in the first figure, which is the top one. So we go ahead and do that command, and so MATLAB now knows this, and it creates this window. But then we go to the plot function and we start plotting things. So our first plot is going to look like x comma sine x. So there's our first plot. And then our second plot, we're going to have to do subplot again, because now we have to tell it that we're putting it in the plot window, and it's still going to be 2, 1, but now we're putting it in the second element. We're putting it in the second window. So 2, 1, 2. And then we do our next plot, and instead of doing sine x, we do sine 2x. Like that. Then we go look at our plot and see what it did. Where'd it go? Where'd my plot window go? Here it is. So, the first one was just that sine of x, and the second one is 2 times the sine of x. And you can do a very nice comparison of them. If you wanted to do more, then you would change the subplot to 2 by 2 or 3 by 1 or 4 by 1 or 5 by 6 or whatever. And you can get many, many plots set up this way. It's a little bit time intensive and code intensive to do this, but it can be very useful in the end. when you're counting the number, which number window you're putting things in, this 1 and this 2 at the end, you always count down, or sorry, you always count the top left as the first one, then you go to the right, or you go down. So you go to the right first. If there's nothing to the right, then you go down in your matrix. And they show that at the top of 164, where if you had a 2x2 subplot, where there are 2 on the top row and 2 on the bottom row, the top left would be p equals 1, the top right would be p equals 2, the bottom left would be p equals 3, bottom right would be p equals 4. Whereas if you just had the 2x1 that we had, then this one is 1 and this one is 2 because there's no plot over here or over here. So if you just have a single column, you just go straight down the column. But if you have rows and columns of plots, you go 1, 2, 3 to the right, and then you count out that way. And that's how arrays are that's how elements are counted in MATLAB anyway. So that shouldn't be any different. Okay, so that takes us to the end of section 5.2. 5.3 will be dealing with some more complex plots using different types of coordinate systems, and we'll be doing some more interesting things with them, get you some experience with that, and then we'll be moving on to, I believe, you get your, I think in chapter 5, you even get your first jaunt into three-dimensional stuff, yeah. We'll do a little bit of three-dimensional stuff even, so that'll be fun. All right, well, we'll stop at this point and let you guys go. Does anybody have any questions before we shut down here? We're all good to go? I've seen that you're all turning in homework, or I've seen a lot of homework being turned in. I haven't had a chance to get in and start looking at it yet, but I will get in and start looking at it this week and start giving you feedback. I usually don't look at it right away because I have students joining the class later, and usually the first homework assignments are pretty simple, so it's not terribly important that you get feedback right away, but I will start giving you feedback. You can go into Blackboard and open up those homeworks after they're graded and see what I've said. Usually what I'll do is I'll copy back in a new, if there's a lot of feedback, like if I have a lot of things to say, usually that means that you've done something terribly wrong. So if that's the case, then I'll copy back a copy of your code with a lot of comments in it. Otherwise, I'll just leave some basic comments in the feedback window of Blackboard, and then you can just go from there. But you'll be able to see kind of the scoring that I gave you, and all those scores will be kept in Blackboard. Don't worry about what Blackboard says you're getting as a grade, because Blackboard's grading features are kind of difficult to manage. I will keep you updated on how you're doing in the class as we go along. It's easier that way. So have a good week.
You too.
Thank you.